Everyone. This YouTube video is on our project, which is early diagnosis and prediction of cervical cancers through deep learning. And in our project guide is MAHAPATRA, Assistant Professor of Admas University. So, in this project, we are uh, actually predicting the cancer of a cell with having our data of about 56 of clinical data, and in between which we are testing some demographic and statistical tests and some laboratory tests, according to which we can perform our model, in which we can uh, uh, classify if it is a cancer cell or not. Uh, so in our data sets, we are considering this four biological tests, which are Hesselman test, Sisler test, or cytology and biopsy, and which are our main target data. These are about overall our data sets. And here our ML, first we are doing in our ML. So in ML, we are taking our these libraries, some NumPy and Pandas and Matplots and Sequence. These are for our calculating and the data read, and this is for plotting, and this is for heat maps or any other kind of visual representations. And in which we have a data on the CSV file, and in which we having these 36 columns and 5 rows for the brief understanding. So we have some historical data and some demographic data, and then we have some our main test of in which we are rely on. So it is total our data shape is 858.36 rows, and this is all the data types which we are working on. And in that we are, and this is the code which our getting the data. Some of are null, so we are replacing with that with some none. And here is after results, and this is our false or true data. And here's the data types again. So, and this is our columns which are repeated, and the first diagnosis and the same time diagnosis which are not useful, so we are drop those columns. After that, we are describe our data again, and this is our mean data, which with the results of the numbers which we get in our uh, total results. And here comes a correlation between all the data, between all the features in the our included data. So there's a correlation between every features, and this is the heat map of every features. So here is the uh, understanding of the correlations of the data, and here is the again the information of the data after complete data frames. Here is the data type and the float type data and other kind of data. And after that, we are just counting of the biopsy test and the number of understanding the importance of or dependent variables in this. After that, this is our split. We are splitting our data into two different categories. So after splitting, we have this number of data and 258 and 33 and 633. And after that, we are run our this split training and test data on random forest classifiers. After that, in random classifiers, we got this fraction of results. And this is a positive of this Sisler test. And here are some demographic, some visual understanding of the Sisler positivity or test, and this distribution of the first intercourse of positivity. And here is the prediction of the accuracy on the random forest classifier. So here we got accuracy of 0.95 of accuracy in F1, and here is the confusion matrix that the here is a top right top left corner we have the true positive, and the top left and down corner we have a true negative of the confusion matrix. After that, we have done our test on CVM, the support vector mechanism, in which we got again an accuracy of 0.95 in this model, in which we have another got confusion matrix of almost same as random forest. And after that, we run our training and test on the k nearest neighbor classifiers, in which our accuracy goes up 0.94 on the train and test prediction. And this is our heat map again of 4E of 0, 2, and the 1 of the true negative. And after that, we have naive Bayes model. In the naive Bayes model, we have the accuracy of 0.18 on the prediction, and here is the true negative and the true positive of the confusion matrix. And here is the complete model of ML, where is the showing the true positive rate and the false positive rate of the uh, our model. Afterwards this we just shifted to our um, deep learning model, in which we test our data on the TensorFlow, in which we have the data set of same with the same data with there is everything the same, the data type, um, so that we changes the nulls and everything as same as machine learning. So after doing all this, there is a mean value of every data also. Then we have the correlation matrix also there. So in this correlation matrix, we have the every age and the diagnosis of the same numbers and the different features. Here is the information of data from the data frame. After that, after NumPy, we have the data save, and then we start the splitting of the training and test data again with the 100, 800, and 700 on the same shape. So we have the result we having 800 and 134 on one side and 158 34 as training and the test data. So after that, we have the feature and labeling of the data, in which training feature shape we have the 833 and 158 of the testing shapes. On that result, we come to our model of sequential as a deep learning model on the keras. So on that model, we have the input and a dense layer. So almost a 32 of 30. There is almost 32 of ReLU activation function, 16 of ReLU activation function, and the final we have the 1 unit of sigmoid activation functions. So this is the our complete classifications of the dense and dense activation functions. So we have the two activations. After that, we test our model's accuracy on a matrix. So after model testing on the features on the epoch of 10, we got our accuracy of 93 0.312 on the validation accuracy of 0.955. The loss of is 0.19. After this, we have the accuracy confusion matrix of accuracy. So we have the accuracy of 0.96 here. And here is the again the confusion matrix for sequential model. And here is some graphical representation of loss in this training and training data. So model accuracy goes almost 0.9330, and the loss we got a 0.18 below of 0.18. So on this note, we have done our test, and that shows the model accuracy, in which we can calculate we can predict the cancer in the cervical. So here is a complete. Thank you.